Hello, welcome to my channel Chemical Chemistry classes. Today we are going to discuss quantitative analysis. Quantitative analysis is the process of determining the numerical composition of elements in a compound. Their main goal is to calculate the percentage composition of each element in an organic compound. Mainly, this quantitative analysis help in deducing the empirical formula and molecular formula of organic compound. First, we are going to discuss about carbon and hydrogen. Right. So, in carbon and hydrogen, what happened? Both carbon and hydrogen present in an organic compound, they are estimated by Liebig's method. What happened in this? A pure and dry organic compound of known mass is heated strongly with pure and dry copper oxide in an atmosphere of air or oxygen free from carbon dioxide. Both carbon and hydrogen present in the organic compound undergo complete oxidation and get converted into carbon dioxide and water, as you can see like this. Carbon with copper oxide on heating give carbon dioxide and copper. Same with hydrogen, when they are heated with copper oxide and it's give water plus copper, right? So carbon dioxide is absorbed in an previously weighing potash bulb containing a string KOH, while water produced and absorbed is previously weighed U-tube containing anhydrous calcium chloride. I will explain you. As you can see in this diagram, this is shown this is used for estimation of carbon and hydrogen. In this, what happened? Carbon and carbon dioxide formed on oxidation of substance are absorbed in anhydrous calcium chloride, here you can see, and potassium hydroxide, right, solution. In this, what happened? The mass of water produced in determined by passing through this mixture is weighed in U-tube. The product is mainly weighed in this U-tubes, right? So carbon dioxide is absorbed in another U-tube and containing concentrated solution of potassium hydroxide. So the strong KOH solution, while water produced, is absorbed previously in weighing U-tube containing anhydrous calcium chloride, and the U-tube and the bulb are weighed again. From the difference between the two weigh, the amount of carbon dioxide and water are determined from this method. The apparatus for the estimation of calcium hydroxide, the apparatus that consists of one combustion tube, has, you can see here, this is combustion tube, a U-tube containing anhydrous calcium chloride, a bulb containing strong, or a U-tube containing strong KOH solution, right? So the tube is heated strongly for 2 to 3 hours till the whole of the organic compound is burned. After combustion is over, the absorption units, the U-tube, are disconnected and weighed separately, right? So how we can calculate? We can calculate like this, like let the mass of organic compound taken is W grams. This is the amount we have taken. Increase in the mass of that U-tube, the mass of calcium dioxide को हम ले लेते हैं X grams. So the increase in the mass of U-tube, the mass of water को हम ले लेते हैं Y. मतलब this is the mass of water and this is the mass of carbon dioxide and this is the mass of organic compound taken, right? So percentage of carbon को कैसे calculate? We can calculate percentage of carbon, like 1 mole of CO2 as we know is 44 grams contains 1 gram atom of carbon, right? So we can write here X gram of carbon dioxide contain 12x is equal to 42 grams of carbon, right? So now 12x 42 gram of carbon is present in W grams of the organic compound, right? So the percentage of carbon in the compound is like this: 2y into 100 mass of water and mass of the compound taken, right? So this is the way to calculate the percentage of carbon, and the percentage of hydrogen is like same. For this, for hydrogen is 1 mole of water is 18 grams. Water is 18 grams, contains 2 gram of atom. 2 gram of hydrogen means 2 grams. So y gram of water contains, y gram of water contains of hydrogen, right? So this 2y18 hydrogen is present in W grams of organic compound. So the percentage of hydrogen in the compound is, the estimation of carbon hydrogen by Liebig's method is suitable for organic compound containing carbon, hydrogen, oxygen only, but it requires some modification for compound like containing nitrogen, halogen and sulfur, right? So the next one is estimation of nitrogen. There are two methods that are commonly used for estimation of nitrogen is Dumas method and Kjeldahl method. First of all, we discuss Dumas method. A weigh amount of organic compound is heated with an excess of copper oxide in an atmosphere of carbon dioxide, water and hydrogen present in the compound are oxidized to carbon dioxide and water respectively, while nitrogen is set free as nitrogen gas. In an oxide, if any oxide of nitrogen is formed during this process, it is reduced back to hydrogen by passing over hot reduced copper gauze. When the gaseous mixture thus obtained is passed through a 40% of KOH solution, that is taken in nitrometer, all gases except nitrogen are produced by KOH. The volume of nitrogen collected over the KOH solution is noted and the percentage of nitrogen is calculated, right? So in this, what happened, we can take organic compound like this, any carbon, hydrogen and nitrogen. With copper oxide on heating, it gives carbon dioxide, water plus nitrogen gas plus oxides of nitrogen, N2, then red hot when they are passed through red hot copper gauze, then these are carbon dioxide plus water plus N2, and when they are passed through KOH solution, then we have N2. So this Dumas method, the apparatus used for estimation of nitrogen is this. This picture is showing the Dumas method, and these pictures are taken from the NCRT, right? So it consists of carbon dioxide generator, as you can see here, CO2 generator, combustion tube, a glass tube that is of diameter 15 micron and length 90 centimeter. The combustion tube is packed with porous copper oxide, as you can see, which prevents backward diffusion of gases, produce an accurately weighing amount of organic compound of approximate 0.2 grams mixed with excess of copper oxide. This nitrometer, the reduced copper gauge, can reduce any oxides of nitrogen back to N2. This nitrometer consists of graduated tube with the reservoir and a tap at the upper end. It has a mercury seal at the bottom. As you can see, this nitrometer has a mercury seal at the bottom, and it has a mercury seal at the bottom that is used to check the backward flow of the QH solution. CO2 generated by heating MgCO3 is dried up by passing through solution, then pass through the combustion tube to displace the air present in the tube. The combustion tube is then heated in the furnace, and this is the furnace. This tube is heated to the furnace. When the combustion is complete, a rapid stream of CO2 is passed through the tube to sweep away the last traces of N2. The volume of nitrogen collected over the QH solution in the nitrometer tube is recorded after careful leveling. The room temperature is recorded and the vapor pressure of the KOH solution at the experimental temperature is noted, and we can make any table. Results and their calculation is same like we have calculated carbon and hydrogen, but I will explain you. In this, what happened? Let the mass of organic compound taken is W grams, right? So the volume of N2 grams calculated volume जो है that is VmL, the atmospheric pressure is PMM, and the room temperature is T degrees Celsius, right? By applying the gas equation, what is gas equation? P1 volume of N2 at STP we have V2 is equal to So the percentage of nitrogen is 22,400 ml of N2 gas at STP, and weight is 28 grams. So the mass of nitrogen we can take as 28, and the mass of the compound So the amount of nitrogen estimated by this method is 0.2% higher than the actual quantity. This is because of the fraction of the small amount of air entrapped in the copper oxide and gets deposited in the nitrometer. Our next method for estimating the nitrogen is Kjeldahl method. In this method, a known mass of nitrogenous organic compound is digested with concentrated sulfuric acid in the presence of little potassium sulfate and little copper sulfate. When the little copper sulfate act as a catalyst when the high nitrogen present in the compound is quantitatively converted into ammonium sulfate. The resulting mixture is heated with axium sodium hydroxide solution, and with the ammonia evolved is passed through the but excess volume of standard acid. So in this method, what happened, this is the apparatus used for calculating Kjeldahl's method, and this organic compound is heated with the concentrated H2SO4, as you can see here, H2SO4 concentrated in Kjeldahl flask. This is a Kjeldahl flask, which is a long neck round bottom flask with a loose stopper. A small amount of potassium sulfate and a few drops of mercury are also added, right? The reaction mixture is heated for 2-3 hours, and when carbon and hydrogen present in the compound are oxidized to water and carbon dioxide, nitrogen is quantitatively converted to ammonium sulfate, right? So carbon dioxide and water vapor escape through the loose stopper, while ammonium sulfate remains in the flask. Right, so the Kjeldahl flask is then cooled and contents of the flask are transferred to the round bottom flask. The mixture is diluted with water and the excess of caustic soda solution, that is added, 40% soda is added, and the flask is then connected to the Liebig condenser through Kjeldahl tap. This is the Kjeldahl tap. The lower end of the condenser is dipped in the non-volume of standard acid taken as a conical flask. This is the non-volume of standard acid, and the flask is then heated and the evolved ammonium gas is absorbed in the acid solution. This is all about the Kjeldahl method, how this operators, how we can calculate this. In this, what happen, how we can calculate, let the mass of organic compound is W grams and the volume of acid taken is V1, and the normality of acid solution as extractor when we added is V2 ml. So V2 ml into N, that is alkaline, is equal to V2 ml into N is acid. So the quantity of acid used for neutralizing ammonia is different, right? So now 1000 ml ammonia solution contains, when 1000 ml of ammonia solution contains 17 grams of NH3, or we can say 14 grams of nitrogen. So we can have V1 minus V2 into N, and we can calculate here is 14 by V1 minus V2 x 1000, right? So we get 1.4 V1 minus V2 by W. So for this we have, last our equation is 14 to M to 2 V minus V1 by 2 1000. So Kjeldahl method is not applicable to compound containing nitrogen in nitro and azo group and nitrogen present in the ring as pyridine structure, as nitrogen as this compound does not change in ammonium sulfate under this condition. So in the next video we will discuss estimation of halogen, sulfur and phosphorus. Thank you.